question, and you need to know how to do this on the quiz tomorrow. So again, London, you'll need graph paper. I'm about to do a problem where we solve by graphing. So we are recording and we are live. All right, so we learned two methods of graphing. We're going to use both of them in this problem. On the quiz, you will use both of them. Don't mix them up. They don't go together. They're both completely separate. So keep them separate.
Is it open yet?
Yep. So one of the methods we learned, it's technically called slope-intercept, but we called it y is all alone. So if you'll notice, y is all alone. So the first way we graph is going to be when you see the variable y. And again, this is only for graphing. But if you see in the equation y is all by itself, and you know you're supposed to graph that, here's how you do it. There. I'm going to try to show as much as I can, but I might not be able to get every. All right, let me zoom out a little bit. Oh, yeah, I can definitely zoom out. There we go. All right, so I have y all by itself. So I know that means I have slope and I have the y-intercept. The y-intercept is always the number that is by itself, not necessarily the last number. In this case it is, but it's the number all by itself. And when I say by itself, it's not with the x, like the -2 is being multiplied times x. -1 is just all by itself. So your first step is to take that number. I already graphed it, but I want to do it again. So we take that number and we say, all right, well, that's my y-intercept. I better put a point on the y-axis, not the x, not the left and right axis, the up and down axis, the y. I just put a number there. There, you got some points on this question already. You're just doing 1 point. You didn't do anything else. You already got some points. Next, I need to know, where do I go from that point? Well, there's only one other number in the equation. So I got to use that -2 somehow. Do not do this. I got a ton of kids still doing this. It is never this easy. You don't just go from here to the -2 because there's a -2 right there. We do not do that. So don't write that. Hope nobody wrote that. We use the -2, but it's not that easy.
1, 2.
We need to go, okay. I know this is my slope. Slope is -2. Well, I also know that my slope formula is rise over run, just like a couple people said. What's my problem?
It doesn't have a run. But
I don't have a run number, right? I got the rise. We can fix that.
1.
Put over 1. If you already have a fraction, you don't have to do that step. If you only have a number, though, you have to do that.
And then instead of rising into the negative, you go down, right?
We will, correct. So now I ask myself, all right, well, which direction do I need to go? I start here. Don't start at the origin. Some people are still going back to the origin. We're trying to find our second point, so we want to start at our first point, which is the one on the y-axis. So start at the point you already have. A positive run is right. Remember, run is always left and right. Remember when I went and visited Mrs. Graff, I went left and right first, then I went up and down the elevator. So left and right to get to the elevator, then up and down. So I want to go left or right first. Well, a positive run means right. Now, rise would be up and down, but if it's negative, that means down. So I'm going to go to the right 1 and then down 2. That's my point. Now you need to be very careful when you draw your lines, because your real question is, what is the solution? It's not just graph the 2 lines. It's what is the solution? If you don't draw the lines very carefully, then they're not going to cross in the right spot, and that might confuse you. So You can use like something that has a straight edge, like we've talked about before, a debit card, another pencil, pen, the edge of your notebook. Or if that don't have that, you can just keep following this pattern. You can go right again and then down 2. Or if you see the pattern, remember, this is actually the same thing as +2 over -1. So I could go left 1 and up 2, left 1 up 2, left 1 up 2. Now I have a pretty good straight line. If I just connect all of those little individuals. That's a pretty straight line if I do that. All right. So that is one of the lines. I just did the line up there. I'm going to get rid of this. But remember, the key is that you need to count whatever the rise and the run are. Don't just go straight to some number that's in the equation. Also, do not mix these two methods up. Do I have y all by itself in the second equation? Is y all by itself in that second equation? No, not even close. Y is like with a whole bunch of crap on the left side. So I am not going to use the y-intercept. I'm not going to use the slope. Oh, I'm sorry. So don't try to mix in y-intercept and slope into this method. This is a separate method. This is the cover-up and solve method. Which needs part of what's up here for that. So for cover up and solve, we're going to cover up part of the equation, the first term, and now we just solve what's left. So by solving, we would say, all right, well, this is -3y, don't forget to include the negative part with it. I need to divide by -3. I don't know if that was somebody joining or somebody asking a question, but it's going to have to wait. And then -3.
What is the cover up and solve?
Cover up and solve. And again, you don't mix cover up and solve with y-intercept and slope.
Wait, you could do
Totally separate. You can't mix and match. You either do it one way or you completely do it the other way.
Question. Oh yeah, because that's why I want to.
So we get y is -6 if we just divide it by -3. Now we have to graph it though. Just because we solved it doesn't mean we're done. We got to put something on the graph. So if I say y is -6, again, I'm talking about y, so I need to use the y-axis for this number. I just come down to -6 and I put a point there. There you go. That's the first point. Not done. We can't draw a line yet. But we just do the same exact process with the other, the other part of the equation. Erase probably some of that line. Yeah, we don't need the y. Y is -6 we took care of. So now we just cover up the other part. And now we solve.
X equals +2.
So if we divide by 9 on both sides, we get x equals 2. Well, now we go to the x-axis because we're talking about the variable x. So we go to the x-axis, which is the left and right axis, and we put a point on +2. Be careful where you put your points. A lot of people do the solving right and then they put it in the wrong spot. It's wrong. Don't give partial credit. Not on that. Well, actually, I even guess partial credit. Depends on how much credit you've gotten. And I always try to find a way to give you some. So now we can connect them. We would say, all right, well, let me go through. Oh boy, that wasn't a very straight line, but straight enough. So we just said the point is not the graph. The point is to come up with the answer. What is the answer to this system of equations? Some of you were in here earlier. Where is the answer going to be?
Yeah, earlier.
Like before the bell rang, some people we already talked about. What is the answer going to be when we graph two lines?
Where the 2 lines meet.
It's where they meet, where they cross, because that point is an answer to both equations. So they cross right there, but you got to tell me what your answer is. You can't just say, oh, where they cross, or can't circle. You got to be able to tell me what is x, what is y. What's x?
-1.
X is -1.
+1.
So again, to find x, I need to use the x-axis. left and right. Well, this point is at the 1. I would need to go to 1 to get to that point first. So x we could say is 1. Then what's my y? On the y. -3. So I would go to 1 first, so x is 1, then down to -3, so y is -3. So that would be the answer. Or if you just want to do it this way, I'm fine with this also. Just label the point. Just say, well, that's 1, -3. That's fine. Either way, as long as you're telling me which one. No, don't write -3, 1, because that is
Can
wrong.
we use this paper for the test?
What do you mean use it? Like as an example?
Yeah.
Yeah, you can use anything you got except for each other in the poems. You can use every worksheet we've done, every graph we've done, any of it. There's only one question that's a graphing, solved by graphing, so I'm not going to spend a whole lot more time on it. Oh shoot, I'm going the wrong way. So now we need to go over word problems though, because there are a lot of word problems. Just setting up the equation. Go. Just setting up equations though is the majority of it. Nope. And we're going to go backwards. So we're going to do the more recent ones first, and then we'll get into some of the older ones. I'm going to probably skip some in here just to make sure we get through everything, because I haven't gotten through everything in most classes. All right. So in this problem, Nevaeh is looking at 2 download services. She's looking at Spotify. Oh, copy this, because otherwise you're not going to have the numbers in the word problem to go with your equations when you use your notes. So just the last 2 sentences. You don't need to copy the first 2 sentences. I'll zoom in for a minute for those of you that might have a little trouble seeing. Says for Spotify, she pays $10, a one-time fee of $10 and then 15 cents per download. For iTunes, she pays $3 and then 45 cents per download. We're doing all the same word problems we've already done, so you might have some of this in your notes. It's up to you if you want to recopy it, make sure you can find it, or if you want to try to search for it. Just make sure you can find it on Friday. That's all I'm worried about. You don't look for it today and you rely on it being in there Friday, you may either struggle to find it, or you may find you don't actually have it written down, even though you remember it. Don't worry about that. That was when we did the lesson, we went super slow. I mean, we're gonna sort of do that. I'm gonna give you some more questions to ask yourself to make sure you can get some points, even if you can't get the whole equation. It's up to you what you write down today. I'm gonna really, really break it down into several steps. But if you think you got it down, you don't need to worry about all the steps. I think you've been doing okay with creating, so yeah, you probably can just watch and just pay attention. There might be a hint here or there that you want to write down.
Okay. Yeah.
Again, write like abbreviations if you can. Well, I guess this one you kind of got to write everything out of there. All right, so I'm going to go ahead and start talking about it. So we have some word problems. There's really just 2 types of equations we could possibly create. There's an equation that's in this format, and there's an equation that's in this format. So those are the only 2 types of equations you can really create. One of those 2 formats. So we just got to figure out which format is in. So I'm going to give you a series of questions to ask yourself when you see a word problem that will answer which way you create the word problem. And once you know which way to create it, plugging the numbers in normally isn't that bad. So here's your first question. So write this down. Actually, I can leave those up there for a second. Your first question you ask yourself is, are there like starting numbers in this problem? Like, is there a number, like before I even, how do I word it? Kind of word it differently, but I don't know. Is there, well, no, we'll get to totals in a minute. Is there just like a starting number? A number that I'm going to start with and then maybe add more to. There's going to be 3 things: starting numbers, totals, and then more what we're going to call final numbers, which is kind of a total also. But right now, you'll see when I give you some examples of starting numbers, it'll make more sense. It's easier to show examples than explain it really with that. So are there starting numbers? A lot of times the starting numbers will be before any time passes, is there a number that you start with? So in this, would you say yes or no, there are starting numbers? Are we going to start with a number and then add something to it?
Yeah, it's me.
No, yeah.
I'm guessing. That's gotta be 10. Yeah.
I'll give you a hint. If it says one-time fee, that's a starting number.
Yeah.
An initial deposit, a one-time fee, those are starting numbers. So, yes, we have starting numbers. So I'm going to erase this now and write the two questions you're going to ask yourself. So first question, we said, are there... Now, normally you would also need to determine, are there two starting numbers or just one? Well, I'm just going to tell you, if they exist, then there are two. Because remember, we're doing systems of equations, so there's always going to be two equations. Normally, the way you would figure out if there's one or two equations is how many starting numbers you have. You have one starting number or two. Here, we definitely have two. She's going to start at $10 with Spotify. She's going to start at $3 with iTunes. And then to that, she'll add more money as she downloads. So again, starting number, and we're adding more to that. That's the key behind a starting number. So then, we'd say yes. Yes to that in this problem. Yes, they're starting numbers. As soon as you see that yes, you're kind of going to be thinking two things. One, there's probably totals there. If I've got a starting number, the only reason I have a starting number is because I'm going to add more to that later. So if I've got a starting number, I should probably have a total also at some point. The total will normally be unknown if you have a starting number. They kind of go together. Starting number and unknown total go together. We're going to come back to that. But that's the way you should be thinking. If I have a starting number, you can even write this down. I didn't make other classes do it. If you have a starting number, you probably have an unknown total also. Because again, if you think of that equation, y equals mx plus b, well, I'll come back to it. I don't want to tell you something out of order. All right, so the next question you ask. So you're almost always going to have totals. So I'm going to make it more specific. So we're going to ask, are there unknown totals? Again, normally you would ask if there's totals and then is there one total or two. I'm just telling you, you're going to have two of them if you have either one. There's never just going to be one total. It's either going to be two of them, and pretty much always two of them. There's almost never a situation where you don't have total. The question is really more, do we know the total or do we not know the total? That's really the question. So are there totals? No, there are going to be totals, right? But we don't know what they are. The total is going to be how much is she going to pay? How much is she going to pay total with Spotify? How much is she going to pay total with iTunes? When he gets back, but I hope you're writing stuff down, man. All right, so, because you missed a lot of class. This is all the review in one. So yeah, we have unknown totals. If you answer yes to these questions, and again, once you answer yes up here, odds are you're going to answer yes there also. Once you answer yes to those, that tells you two things. So yes answers. And I'm also going to write unknown totals because unknown totals and starting numbers. So that's what we're answering yes to right there. If you have yes answers to those, that tells you two things. One, the format of the equation is this. That's the format of the equation. And then two, where is a total normally, what would represent the total if we don't know it? Like, how are we going to represent a total or any unknown number if we don't know it? No, because we don't have a C. We don't have that equation. But you're kind of on the right track. What would represent an unknown total? What would represent any unknown? What do we use to represent unknown?
One.
Variables, but y is going to be the total. We would never use x to represent the total because we're adding something to x, right? Actually, we're multiplying something times x and then adding something to it. So it can't be a total because we're going to be adding more to it. The total has to be the thing that's all by itself, the y. So the second thing it tells you, if you answered yes to both of those, it tells you y is going to be your total. Total is plural. And again, you'll have two equations, so you'll have a y in one equation and a y in the second equation. So we know in this problem, we have yes answers to those equations. We know our format is going to be y equals mx plus b, and y is going to stand for our totals when we start that equation, or when we create that equation. I'm going to have to erase all of that, so make sure you got it down. We'll start up here, I guess.
Oh. They're good.
Ooh, I'll bet this works. My long distance eraser. Look at that. Pretty smart, big brain. Everybody looks like they're about done. All right, so now we're going to create equations. What do we start with in our equation? What's the easy, one of the easy things to start with, now that we've answered all those questions?
Y equals mx plus
We know it's going to be y, and what do we say y equals?
the total.
So we know we're going to go ahead and start with a total. Change colors. That's going to be one of the totals for one of the services. We'll say Spotify is red. No particular reason it's red, we're just going to say it's red. What's another thing that better be true when we create this equation? So another thing that's really simple to get some points. What's true about the numbers in this word problem that we better do?
It says y times p, so 1 times p is 3 hours.
Yeah, but before I even worry too much about where they go, I'm just going to tell you because I got to get things here. What are the 10 and the 15 cents about? If something's about the same item or person or whatever, they better be in the same equation. I better never see you put 10 in one equation and 15 in another equation. If they're about the same service in this particular problem, they better be in the same equation. So if this equation is about Spotify, let somebody in. If this equation is going to be about Spotify, then it better all right, so I'm doing a review. You guys that are late, you've missed a little bit. Not tons yet. You missed graphing, basically. So my numbers about Spotify better be the numbers in this equation. I shouldn't see any numbers that are related to iTunes in this equation. This equation is not about iTunes. We're going to create another equation that will be about iTunes, and we'll put them in there. But you shouldn't be putting anything about iTunes in this equation. Only the Spotify numbers. And this is the Spotify total. We don't know what it is, but that's what that represents. So now I just got to say, okay, well, what's the first number? Like, what's my start number for Spotify? 10, right? And then to 10, I'm going to do what? I'm going to pay that $10, but then what am I going to do?
Place that 15 for the songs.
Every time I download, I have to add more money to that. So I'm going to add.
15.
We really haven't done much subtraction in equations, so that's a pretty safe bet you're going to do add. And then what number am I adding? Every time I download a song, I have to add 15 cents. So what am I missing? Am I
The
done?
X.
No.
The X.
Don't have the X, right? Where's the X going to go?
Behind the 15.
How do you know?
Because it's per download.
You don't know
So
how much
for
you're-
download, how does that mean? Why does that mean it goes behind 15?
You don't
You don't know how much you're gonna download.
Well, we know it, it's an unknown, so that's why it's gotta be the X. So X has to be the, because we know Y is the total, so X has to be the number of downloads. So again, why does it go with a 15? We know it's the number of downloads, so,
Because it's unknown.
no. Why didn't he go with a 10?
Amounts of downloads are unknown.
Because the 10 is how much we know we're gonna put. We know we're gonna put $10. We don't know how much the song's gonna be.
And I think you guys understand it, but I still want to explain it in case other people don't understand what we're saying. I don't pay that $10 every time I download a song. So I wouldn't want to multiply it times the number of downloads. Like I pay that $10 and I'm done. If I download one song, I still paid the $10. If I download 100 songs, I still just paid the $10. The 15 cents though, I pay that every single time I download. So that's what I would need to multiply times the number of downloads. So that's one way to understand it. Basically, the 15 cents is the rate of change, and the rate of change is always multiplied times the X. So there's one way. I'm going to give you 3. Number 2, not sure if this is easier than the third one, but it's pretty easy. Don't ever multiply X times the startup fee. Never. Startup fee will never, ever, ever be multiplied times X, because if you look at this equation, this is the startup fee. It's not multiplied times X in our equation, or it's like our Y equals MX plus B. So don't ever multiply it times X in the equation you create. So there's your second thing. Don't ever multiply X times the startup fee. Got that? Everybody wrote that down? Don't multiply X times the startup fee. Because I've still seen like 3 or 4 people not write it down. Right, Michael? Hey, welcome.
What is it?
Don't multiply X times the startup fee. So if you identified which number is the startup fee, don't multiply that times X. Multiply the other number. There's only 2 numbers. So multiply the other number times X. And here's the last way. If you read the word problems, and again, this won't apply probably as much next year in algebra as it does the quizzes I make up. Look at the problem. Look at the wording in the problem. 15 cents per download. 45 cents per download. Write this. Not always, again, especially next year, but a lot of the time. Those words kind of mean multiply. So all 3 of those words mean multiply. So it literally means 15 cents times, because we got the word per, which means multiply, and then the downloads. Well, we said X is the downloads, so it's 15 cents times downloads. So that's the third way to remember where the X is. If you see any of these words, like, well, we'll do another one in a minute, you'll see. All right, so I went really slowly through that first equation. We're going to go faster now because they're all just like that. Once you've identified, the hardest part is identifying which type of equation. Is it y equals mx plus b, or is it the other one, a times x plus b times y equals c? So now then, iTunes is going to be the same concept. We had a total. What's my starting number for iTunes? 3, right? Hopefully you're just copying, which is fine. I'm then going to add to the 3 more money as I download. So I'm going to add to that 45 cents. Again, per means times, and then download is the X. So I'm going to take the 3, and then as I download, I'm going to add more money to it based on the number of downloads. I'm not solving anything out right now. If we were going to solve out, though, we would basically just set those 2 little expressions equal to each other. 10 plus 0.15x equals 3 plus 0.45x.
Can I get the background for this?
Yep. So now, next one. Oh, come on. Okay, so here's the next one. What's the first question you asked?
Oh, I asked myself the first question. Ask yourself, when creating a word problem, are there starting numbers?
Are there starting numbers in this?
Yeah.
Yes, 120.
Yeah, before any time passes, they have money in their account already. They both do. Now, 0, by the way, can be a starting number. Maybe one of these guys hadn't saved any yet, but he's going to start saving. This starting number could be 0. It's not in this case, but it could be. So don't think that just because there's like they don't have anything, that doesn't mean there's not a starting number. 0 can be a starting number. In this case, that's our starting number. Oh, write down the 2 middle sentences. So from here, again, because you need to be able to match this up with your equations and what's in your equations. So between those brackets, write down those 2 sentences.
Okay, get it, everybody.
Hand off.
Oh, yeah, literally just something.
And you can kind of be thinking about the questions. We've already kind of answered one. Yes, there are startup numbers. They have some money in their account before we start saving every week. So if we've answered that, we're already kind of thinking that we know the way the equation is going to set up, which is going to be what? What's the equation like format going to be? So it's either going to be this format or this format.
What you said?
Well, we're going to confirm it with a second question, but it's always going to be one of those 2. It's always going to be one of those 2. But if we answer yes, there's a starting number, we're already kind of thinking, okay, if there's a starting number, it's probably going to be this top. Because remember, this is the starting number, B. That is the starting number. There's no starting number in this. There's nothing that's just a number by itself except for this, but that's going to be a total. So there's no starting number in that second type of equation. That's why that's the question you ask yourself is there a starting number? So how do we confirm? What's our second question then? Once we say, yeah, there is a starting number.
Second question is to ask yourself when creating a word problem are there unknown totals?
Do we have unknown totals in this? And again, you're
Yes.
thinking that we should because you said, yeah, there's a startup number.
Yes.
Yeah, absolutely. What's the unknown total?
Seeing how much money they come up with.
It's how much is in their account at any given time. Like it may be after 2 weeks, it may be after 7 weeks, it may be after 20 weeks. But the unknown total, the unknown amount in their account is an unknown total. So yes, we've answered yes to both of those. So we know it's going to be this right here. It's going to be that type, not this one. All right, so now we can start creating our equation. That's, like I said, once you determine that, creating the equation is not hard. We know we got a total, right? Y is always going to stand for the total if it's unknown. We said that earlier. So we know Y is the total. So make sure you write that. If you didn't already write it earlier, if it is an unknown total, Y is going to stand for the unknown total. Always. So that's all you got to answer. If there's an unknown total, then you know Y is going to be the unknown total. What's our starting number then? We'll do Julian first.
120.
120, right? And he's going to do what to that 120?
At $20.
He's going to save money. He's going to add to that. What's he adding?
20.
Again, I better never see 120 and 20 in a separate equation. They go together. They are about Julian. 120 is not about Christian. 20 is not about Christian. So those better be in the equation that's about Julian's money. And then, where does the X go?
Right behind the 20.
Yeah, it's $20 per week. $25 per week. It says every, but again, that really means the same thing as per. All those 3 words mean multiply. So we're going to say 20 times. So what does that mean X stands for? What would X stand for then? Yeah, it's literally the word that is right behind the number. So 20 per week means X stands for week. 20 times weeks. 20 times or multiplied by the number of weeks. So it would stand for how many, by the way. You can't just write weeks if you define it. You have to say how many weeks or the number of weeks. So next, I'm not even going to switch colors. Now we do Christian. What's he start with?
10.
He's gonna do what to that 10?
Add it to 25.
You're gonna add 25 per, so times the number of weeks, which is X. Should start to kind of be comfortable with this type of an equation, because they're all virtually the same. Once you identify that the format is this format, they're not super difficult, I don't think. Any questions? We're gonna do another one. Actually, we're gonna do 3 or 4 more. I mean, they may not be like this, but 3 or more word problems, setting them up.
Might get better than that.
All right, so we're done with that one. Well, again, I'm not going to solve them out yet. We'll get to that when we do solving by substitution. All right, so here we go. Another word problem. First question is what?
See what,
Are there any starting numbers in this?
Yes.
where, come on.
Uh-huh.
Yep.
Like literally one of them is called a head start. That's my starting number. I get a start. So yeah, they're definitely in this, no doubt. What's his starting number? Contrast.
0.
Yeah, he's at 0, but we said that can be a starting number. Doesn't have to be a positive number for it to be a starting number. So yes, absolutely. So now we should already be thinking there are going to be unknown totals. Are there unknown totals in it then?
Yes, yes.
What's the unknown total?
When they'll meet up at each
When they catch up.
to each
Well,
other.
what are we measuring? That's not a total.
Yards.
That's
There's not.
Yards.
Yeah, the number of yards, the total yard, or the total distance, you could also say. How far we travel to, because I'm starting at 20 yards and adding 6, so it's my total yards. He's starting at 0 yards and traveling 8 yards per second, so it's his total yards. So there are totals. It's not about money, and it won't always be about money. A lot of times it will. So just remember that unknown totals don't have to be about money.
Do you want a story from Mr.
So if we know that's the case, ooh. Actually, I don't mind that being lower. That'll work. Yeah. So if we know there's unknown totals, and if we know there's a starting number, then that's the way we're going to write it. Y is going to be the total.
Do you want a story from Mr. Gills for a second?
Yo, good idea. Yeah, you don't need the first sentence. But again, so this matches up. You kind of have to write that, but then you got to come down and write this also. Mr. Gill, you don't really need the if, but yeah. Yeah, I'm glad you mentioned it. Because I know you guys have the equations in your notes, but you don't have the word problem part, and that makes it really hard on quizzes. I didn't really think about that in the past, making sure you wrote down that stuff. So I got to start doing that moving forward. You can actually, if you get it copied, try to create equations on your own. You know the format now because we had a starting number and unknown totals. You know Y is always going to stand for the unknown totals. So you just got to plug in, you know X is going to be on the other side somewhere. So you just got to plug in the correct numbers in the correct spots. So I'll give you a little extra time to write it down because I want everybody to try to do it on their own. I'm not going to set the timer, but I'll probably look in like a minute. So like when the big hand gets a little before the study. Again, it's not for, today's not for a grade, it's just because you have a 100-point quiz coming up in 2 days. And I'll be the first to say, I don't normally say this, based on what I've seen over the last week or two, this is going to be a hard quiz. Normally I say I don't think it's too bad, but relative to what I've seen, and although you guys are doing really well today, so hopefully it won't be as hard as I'm thinking it will based on what I'm seeing in other classes. But 6th period struggled when we did the review. 4th period did fine. 5th period has really struggled. 1st period has struggled. You guys are doing much better than those other classes. I always wonder why that is. Same material. I won't teach it that much. If you go back and watch the review from yesterday, it'll be a little different, but not that much different. So go ahead and try to create the equation also. If you have the equations, I'll check them real quick. Try it on your own though. Don't sit there and just copy what I copy.
No, they were in the car. Okay.
And then when we would solve it, like if that, well, I'm not going to solve these. We'll do. But how do you solve it? How do you solve it? You want to give me x and y. What is the x and y that are answered? What is the number of seconds that go by? What is the total yards that go by? X and y equals. Remember when we did substitution and you had equations like this? Y equals all of this? You know. Well, that's one way we did it. That wasn't substitution, that was elimination. And that is a way, you could do it that way. But we did another way.
Just,
We know this is equal all of it.
usually we're, you know,
So
that's what
y
it's
equals
called.
y. We also have y right here. I used to say, well, this is the same thing as y. We just call this, right here, and now you have two equations equal each other, and you can solve that. Fantastic. Good. That's it.
Mr. Gills can check them out.
Yes,
But he had extra numbers.
I'm about to show it.
Can I solve it?
It's good. Check one
Well,
out.
again, what is my, that's my rate, right? Did I start at 100 yards? Am I starting with?
Yeah,
It's good. Can check one.
that's what they're gonna run.
Well, that's how far we're gonna run. Is that where I started? I started at 100?
No.
Then that's not my starting number. Well, remember, I threw an extra number in this one. That's throwing a lot of you off. Did I just step on your foot? I'm sorry. I thought it was gonna be a backpack.
Is that it? You're good?
Yes, good.
You come check one, Mr. Gill.
Can I go to the bathroom?
We're the equation, buddy. See the equation.
It's like
Yes,
20 people
yes,
on-
perfect.
Check one. Mr. Gill.
I think everybody's doing pretty well. I'm just gonna put the answer up so that we can move forward. Did you solve it already? Yes and yes. Good. All right, so real quick, I'm gonna kind of do this fast because everybody looks pretty good.
Right there.
If you have questions, again, this will be recorded twice. So I know the format is y equals mx plus b. Y is gonna be the total yards. So my total yards is gonna be made up of where I started. Where did Mr. Gill start? So a lot of people put 100 in here somewhere. The 100 wasn't a starting number. That actually wasn't any number we used, to tell you the truth. That was just to help you figure out who would win the race. So it wasn't even something you used in this equation. So the starting number, just be very careful when you figure out that's the number I'm going to add to as I run for me. And what am I going to add to that? What do I add to that 20? Yeah, it's basically the only other number that's about Mr. Gill, right? All the numbers that are about Mr. Gill better be in this equation. And then that is 6 yards. Again, it says right there, 6 yards per, which we said means multiply or times, per, so times, and then seconds. So what does X stand for then? Stands for seconds, whatever that word is, every single time. This will always, now it would be the number of seconds, if you wanted to really be, or how many seconds, but the word problem tells you exactly what goes in here. So now, Contreras would be what? Where does he start?
0.
He's at 0. Yeah, he didn't get a head start. He starts at the starting line, which is fine. He can start there. And then he runs at, again, 8 per means multiply, and then times X, because X is going to be the seconds. 8, well, for him, it's going to be 8 per second. So those equations are all very similar. The process, how you find the numbers, what you're looking for, everything.
Will we have to solve the?
Yep, some of them you do. But I'm not going to solve because we're going to get into solving later when we just have like substitution and elimination and all that. And frankly, I don't care how you solve it, as long as you get the correct answer. You only solve, like, it's either 2 or 3 of them. So there's 2 more word problems, and then we'll get into solving. And we already solved by graphing on one. All right, so here's your last one. All right, what's our first question?
Is there any starting numbers?
Yeah, that's my first.
Are there any starting numbers? Plenty of time. Are there any starting numbers?
No.
Yeah,
Oh,
no.
somebody said no.
No. There's a
How do we
total.
know?
Errands are $1 each and honey buns are $2 each. He spends $15.
All right, so here's how you know. Those of you that aren't sure, you guys are right. There's no starting numbers. Here's how you determine whether or not, like if you're not sure, sometimes it's really easy. And I'll tell you right now, normally a starting number is pretty easy to figure out. Because you're going to take that number and then you're going to be adding more to it. Either adding more money or more, in the case of distance, we added more yards. So the first question is there some number that I'm going to take and then add more to that? Well, I have a 15, so here are the only numbers I have. And by adding, you're not going to, oh, and I need to write something else up.
A 1 and a 2.
So that was the second part that we added when we did the lesson later. But you need, oh, so again, write this information. So you're writing from here to here. Then ignore that sentence. And you need this. And then you're also going to write, after you do all of that, you can go ahead and just put X equals the number of airheads. And then you can just write Y equals the number of honey buns. You can write those words out, but I'm just doing it. To the nurse? All right. You're going to miss the rest of the review. Really good if you can hang in there.
Can I go Lily come second?
What's that?
Can I go Lily come second?
Yeah. I don't think anybody. Was somebody else waiting after me?
Me?
Were you?
Yeah.
No, he wasn't.
Somebody, I think somebody else was. I actually thought she was supposed to go after me. Did I get that out of order? Were you supposed to go before? No.
I was after.
All right.
What up, boy? Son.
Well,
Junior. Junior.
he's going.
Garrett.
He's paying attention and working there. Isn't he?
See, Mr. Yeah, I'm doing something, boy.
All right. So, write all of that. Should be pretty much done. Again, here's what you need to, so in order to answer that first question, because sometimes it'll be a little tricky. If you don't immediately say yes to are there starting numbers, then there's a good chance there won't be, but you need to still figure it out, just in case. Because normally starting numbers are pretty obvious. Like we take a number and we're going to be adding more to that number. Well, in this case, here are our numbers. We got a 15, we got an 11, we got a 1, and we got a 2. So now let's see if any of those are starting numbers. Is 15 a starting number? Are we going to add more to that? No, not really. I mean, 15 is more of a final number. So that's more of like a final number. And I'll tell you right now, if you have a total, so that's like a final, or it's really a total, this is the same. What it will is 11 a starting number. We're going to add more to that.
Well, how do you know you bought 11 items?
Because that was part of
He
the problem.
made that up.
I didn't include it when we did the lesson initially, but then I gave it to you later. I just never typed it in. I just wrote it in. So 11 then, is that a starting number or is that more of like a final number?
I knew that was
Huh? Is 11 a starting number where we're gonna like add more to it, or is it more of like a final
11
number?
is like
11 is
No.
adding to
you
it.
spent. You got 11.
What are we gonna add to 11?
Nothing.
If we're not adding to it, it can't be a starting number. You will always be adding something to a starting number. So that is not a starting number. That's more of a final number. All right, so here's your next thing to write down, or a total, you could say. And again, this won't be the same all the time. It will in my class for the most part, but when you get to algebra next year, the problems will get a little more complex. So this may not apply, but for this year, it'll be safe. If you know the final number, or if you know the totals, you know, that's why I don't like people getting up and doing their own thing. So, if we know the final numbers, which we do, we know 15 is the total he spent, it's a final number. He ended by spending $15. He ended by spending buying a total of 11 items. So the totals in this problem are known. We know, like before we didn't know what the totals were. We were trying to figure them out. If we know the totals, so I'll write it down here. I'll scroll up in a second. This, I'm writing it more for the people online, really. There. If you know the totals, then that's the format you're going to use, most likely. It is possible, I mean, again, that's not 100% of the time, but most likely, if you're given two totals and you know the number for those totals, you're looking at using that type of equation. And again, the second question would be, or the second thing that would make me think that there's no starting number. If there's no starting numbers, we also would use that. So you could kind of also write that in here. And there aren't any starting numbers. So also if there are no starting numbers. Because this kind of an equation doesn't have starting numbers. Like there's not a number that we're starting with and then adding to that. We're always multiplying something times one of the variables. So if we know the totals and there are no starting numbers, that's the equation we're going to use, that format. And both of the equations will always be in the same format, by the way, for the most part. Again, I'm not saying that won't change next year, but this year they'll be in the same format.
Can I ask you a question about next year?
No, not today. We're getting through a review today. Today's a review day. We'll get into questions about next year, next class. Or you can send me an email. All right, so I got to get through this because I'm recording it, remember? So I got to get through it for all the classes, not just this class. So I'm using that format. Hopefully you have that written down now because I'm getting rid of it. Should I leave? You should have all that other stuff written up. So I'll start by erasing that. I guess I need to erase all of it. And I was going to try to leave some of it up, but I cannot. So there you go. This will be recorded if you really, really need to go back and catch up on something. All right. So now we know our format: AX plus BY. What is the total? Or not what is it, but where is that normally going to go in an equation? Where's our total there? Even if we don't know it, it still kind of goes in the same place, sort of. Where's the total go?
Huh?
It's the last, it's all by itself, right? Y is all by itself when it's the total. Well, here the total is going to be all by itself because it's what everything adds up to be. It's the total. So the C variable is the total. So when we said AX plus BY equals C, C is the total. You could literally do this on a quiz and nothing else and get some points. For those of you that really struggle with the word problems, that'll get you some points. I know totals have to go at the end, and I know 11 and 15 are my totals. So start with that if you're struggling on this. Or even if you're not struggling, you can do this.
Well, probably something weird.
So now you can kind of work your way into the rest of the equation if you start with that. That's why I say, even if you know what you're doing, that's not a bad place to start. What is the 15 about? Like, what's that representing? Money, right? That's about money. So I would say, I don't care if you write this in on the quiz. Go ahead and write money in. That's about money. What other numbers are about money in this word problem?
Yes, it is, bro. I think he's tripping. I think so.
Oh.
I do too.
What other numbers are about money? Oh,
How much
Michael,
money
it's
bucks
Kylie.
cost?
Let's go with Kylie.
Oh.
What other numbers are about money?
Cut me off like that.
Honey buns are $2.
$2, right? What else?
Airheads are $1.
So if I have some numbers about money and some numbers not about money, then all the numbers about money better go in the same equation. Now, sometimes all the numbers will be about money. So we got to do something different. Like, it might be how much money Jim paid versus how much money Lisa paid. So all the numbers would be about money, but some numbers would be about one person. The other numbers would be about the other person. In this case, I have some numbers about money, some numbers not. If it's about money, it better go in the equation that's about money. Again, you need to match up the numbers together in the correct equation. I should not see 15 up here and then the 1 and the 2 down there. If they're about, and you could even do this, again, show me they're about money, I don't care, that's fine. Doesn't change the equation. What am I missing?
God.
I'm not sure you've had that conversation, so I'm not sure how you're. So, what am I missing in this equation? I got a 1, a 2, and a 15. I need variables, right? That's the whole point of an equation. I'm trying to figure something out.
X and Y.
What I've already told you what the variables stand for. What was X about?
X is airhead.
Airheads and
So
Ys.
which money number is about airhead?
1.
So guess where the X goes?
X goes by. No, it goes by
Behind
11.
the 1. Yes, sir.
Goes with the 1. What variable is about honey buns?
Y.
So guess where that goes?
Right behind the
Oh, I'm
2.
sorry. What number is about honey buns?
Little 2.
So guess where the Y goes in?
Right behind the 2.
And I'm adding together because however much money I play plus however much money I pay is going to be my total. There's your equation.
Wait, where's the 11?
Well, we're going to do that next. That's what we're about to start talking about. So now let me ask you this. What is the 11 about?
Oh.
How many items? So not about money. No more money numbers.
Dang.
So what is the total number of items made up of? Like what goes into making up that 11? Yeah, it's the number of airheads and the number of honey buns. Again, not about money, just about how many of them. Well, what represents how many airheads?
2.
Does it say 2 airheads somewhere?
I think
That's how much an airhead costs. I just want to know how many airheads. It's just a variable, right?
Yeah.
We don't know anything except for the variable is how many airheads. So we would just say, okay, well, the number of airheads or how many airheads,
5 airheads and 100.
and then plus how many honey buns equals 11. So again, if you read this back to yourself, you know what X stands for. You know what Y stands for. Replace those variables with the words that you have literally written down. I told you what they were. You don't even have to figure it out. So replace the variable X with the number of airheads. All right, the number of airheads plus Y is the number of honey buns. So the number of airheads plus the number of honey buns should that be 11 based on the word problem? Well, yeah, if I add up all of that, it should be a total of 11 items. So you can kind of go backwards once you create the equation and use the words that are right in the word problem. I mean, I told you what they stood for, and I do that in the quiz too. I think I tell you there might be one problem where you have to come up with what the variables stand for, but I tell you every other problem. So you could say, well, does the number of airheads plus the number of honey buns make sense that they have to add up to 11? Yeah, because that's the total items of that. I'm not going to solve that one out because, again, we'll get to solving in a second. Boy, I got to get through some stuff pretty fast. So, find the value of two numbers. Sum is 4. I'm still mad every time I see this. I'm going to do the quick version of this because we did it so many times before the last quiz. I have two numbers that I don't know. That's going to be my unknowns. I don't even really have to describe them any other way. One's going to be one number, one's going to be the other. X is a number, Y is a number. There's no relationship between them or anything, so I just put X is a number, Y is a number. What do I know about those two numbers? What's sum mean?
Some mean the equal.
No. Is means equal. Remember that. We said that. Boy, I'm glad you mentioned that. Is means equals. Remember, you wrote that down a while ago. I'm so glad you mentioned that because I didn't talk about that in any other class. I bet they don't go back and watch the video. Is means equals when we create equations. So that's hugely important sometimes. So their sum is 12. I can go ahead and write is 12 right now. Is 4. I can go and write equals 4 right now. I hope you all just got that because that's easy points. If you missed that, that's your own fault right now. You're the only class that got that information.
Hello, Mr. Gill.
Is 4 literally means equals 4. I mean, you want to check and make sure that makes sense. Like, does it make sense for me to say equals 12, equals 4? Yeah, that makes sense. Then you can write it. So now I just have to understand what sum means. Lord. Sum means what? S-U-M. What kind of math? Well, it's the total of what kind of problem? It's addition. So their sum means you just add them together and they got equal 12. What's difference mean? I mean, it's literally right above the words. That's it. That's the problem. We did that 3 times before the last big quiz. I think I got like 10 people that got it right. They completely right. And it made me pretty mad. So that's why it's on there again. So we better do better on this time. All right, so write that quickly because I got to go. 5, 4,
Let's go,
3,
let's go.
2, 1. Oh, you should have written two numbers have a sum of 12 and a difference of 4. So you know what goes with those equations.
Oh, I did it.
Two numbers have a sum of 12 and a difference of 4.
Two numbers if their sum is 12.
Because that otherwise you won't know where those equations came from.
And their difference is 4.
All right, so on to substitution. I'm going to skip some of these to make sure I get through everything. If I was solving this first one, though, I know y is equal to this. Everything in that box is what y equals. In this case, it's just -6. So I'm going to follow the same process every time. I just plug in -6 here, and I solve out for x, and now I know what x equals. I'm going to skip that one because it's pretty easy. I hope you're able to do that. If you need to watch the video, I did it in 6th period yesterday, so you can watch that video. Now, let's go on to one that's a little tougher. I know x. I know x is 2y. That means everything in that box is the same thing as x. So I can come to the other equation and get rid of x. I don't need that anymore. I know x is the same thing as 2y. Lily, this way, please. I'm trying to ignore it, but it's getting too much. Gentlemen, ladies, too much. Talking, yelling over just you two right now. Please stop. I know x is the same thing as 2y. So I can get rid of that x and replace it with the 2y. That's substitution. I'm taking something out and replacing it with something that has the same value. Now I have an equation I can solve. One variable, one equation, I can solve that. I would bet some of you would solve this wrong, because I've seen it on the quizzes when I've had something like this on there. This is not a two-step equation.
No.
We do not say plus 6y and plus 6y. All that does is just move the 6y to the other side. we don't ever want to move variables. We only want to cancel variables from this side. Well, we don't have any variables over here. We don't need to do anything with variables over here. We just need to combine these. Those are just like terms. You have 16y subtract 6y, that's 10y.
Yes, sir.
Think of it as a physical thing. 16 yo-yos, that starts with y. 16 yo-yos. I subtract 6 yo-yos. I have 10 yo-yos left. And then I divide by 10. Last step is still always division. So that gives me y equals 3, but I'm not done. Every single problem, I want to know what x and y equals.
Now you just fill it in, right?
So now I need to say, okay, well, if I know y is 3, I can come back to my two original equations. You can make any equation that has x and y. Any equation. I'd pick the easiest equation, which in this case to me is the x equals 2y. X equals 2y. I know y is 3, so x is just 2 times 3.
Oh, x equals 2. Wait, what?
That's why you need to pay attention.
X equals 2y times 3. X equals
Nope,
2.
x equals 2y, which means y is 3, x equals 2 times 3. All right, you can go back and watch it on the video, or you can start paying attention.
Yeah.
So now, same process. If I see that there's a variable all by itself, again, this is not for graphing. We could actually graph these because we have them set up in a format that we could graph. Y equals mx plus b, y equals mx plus b. Problem with graphing is we got to put a y-intercept of negative 22 and a y-intercept of positive 13. That's hard because the graphs don't go up that ladder. So we're going to substitute. I know everything in that box. This is the way, by the way, you solve some of the word problems. A lot of them. Because we have y equals an mx plus b and y equals an mx plus b. I'm going to, so when you solve a word problem, this is the way you do it. You may want to make a little note. This works for word problems next to this problem. I know that all of this right here is the same thing as y. Well, then I'm going to go to the other equation and I'm going to replace that y. I guess I'll do it down here. 3x plus 13. So I just replaced that y.
When there's two, yeah, okay, you do
There. And then I just write what's on the right side. I don't change anything on the right side.
it.
Now there is an equation on there that's similar to this sort of that you have to solve. Like it's just solving equations. It's not a word problem. It's not solving by substitution. It's just an equation. There are a couple of equations, actually 5 equations on there that are just solving equations. Again, I need to eliminate all the variables on the right because I want all the variables to wind up on the left, right? Because my final answer is going to have, you know, x down here equals some number. So that means I need to get rid of all the variables on the right and then get rid of all the numbers that are on the left. And that'll leave me with just numbers on the right, just variables on the left. So to get rid of this, I need the same number, opposite sign.
So this is basically a simplification.
That's kind of like we did in the elimination, if you remember. Whenever we were trying to eliminate terms, we needed the same number, opposite sign. That's why, because that's what eliminates equations from variables. So I have same number, opposite sign, so that goes away. But if I do it on that side, I have to do it on this side. Make sure you keep the x's together. Don't put that 2x under 13, because you can't solve that. You can't add 13 and 2x. So now I have negative 22 still on the right. But over here, my equation is 5x plus 13. That's a 2-step equation. And there are 3 2-step equations on there. They're just already given to you as 2-step equations. You just have to solve them. So I'm going to use this as kind of practice for those. So if you see an equation like that, I need to get rid, so I've already gotten rid of all the variables on the right. So I don't need to do anything on the right. I need to get rid of these numbers though. So to get rid of the numbers, I always save the 5 or whatever's with the x for last, because that'll be division, and that's last.
And you do the opposite.
Same number, opposite sign, just like when we do elimination, which we'll do in a second. Same number, opposite sign. That cancels them out.
And if you do it to one side, you gotta do it to the other.
And then Mr. Gill's number 1 rule, if you do it to one side, you gotta do it to the other side.
Yeah, sounds better. Okay. So you get an eight and
Damn.
Yes, I do.
Damn.
You ain't even see my test screen. Ben, stay here. What?
So if we divide by 5 as our last step, remember division is still the last step when we solve equations, x is -7. But we're not done.
God dang.
We don't know what x is.
Oh, we just got it.
I'm sorry, we don't know what y is. Which one did I do? Oh, I'm up here. So I don't know what y is. Again, I can pick either equation I want. Doesn't matter which one. I'm not even going to do this one. I did it on the. If you really want to watch, I did it yesterday. You can go back and solve it out. So I would plug in -7 for x, do the math, and I think y is -8. All right. So the last type of problem, you don't even have to solve this out on the quiz. You only have to do the very first step of just substituting it in the right place, right thing in the right place. Same process. I know everything in this box is what y equals to. You're going to pick the one where the variable is all by itself, by the way. So you pick the equation where the variable is all by itself. So I know all of this in here is the same thing as saying y. All right, well, then I can rewrite this equation. I can't do anything with the x. You never replace x's where x's are. I won't change the 3, but the y, this is all the same thing as y. So I'm going to get rid of that. I'm going to use parentheses. And that's my new equation. Now I have one equation, one variable. I would be able to solve that, but you don't even have to solve that. That's all you have to do for full credit on that problem. You just plug the right thing in the correct place in the other equation. All right, so now we got to get to elimination, and then we still have to do one practice equation. So I'll probably skip a little bit. What then?
The equation.
I said I'm not solving that. Well, you don't have to solve that one out on the quiz. You're talking about the one we just set up?
Yeah.
Yeah, we don't. You don't have to solve that out on the quiz. It just says just replace,
Okay.
just substitute.
Ah,
All right. I'm not going to solve this one out, but I'll talk about it real quick.
okay.
What is our goal? So we're solving by elimination. So you can kind of make this note so you can find this. I tell you this way, please. I tell you on the quiz how you solve. So it shouldn't be hard to figure out, do I do elimination, do I do substitution? Now, I'm not saying I'm always going to tell you that. I do on this quiz. On the final, I probably won't tell you that. So, elimination. What is our goal when we solve by elimination?
To get it myself. Do something myself. We're trying to eliminate stuff.
I mean, but how?
Trying to
That's like
eliminate.
saying, well, we solve for the variable. Yeah, how? How do we do it? What's our goal?
Trying to eliminate stuff.
What is going to allow? Well, what's going to allow us to eliminate stuff? What do we have to get before we can do
Replacing
that?
it.
No, that's substitution.
Those are variables. I mean, those,
Canceling it out.
yeah, cancel out.
So how do we do that then? What do we have to
That
get?
negative
What's our goal?
5y, that positive 5y, you cancel it out.
But what if it wasn't set up like that? What do we have to get to be able to do that?
That equal sign right behind it. You
We
press
flip
add.
all the signs.
No, I made you write this down. It's in your notes. So you can't say it. You better be able to find it, or you better write it again in a second.
So what are we saying?
We need, before we can do the elimination part. Yes, that's what we're going to do, but you got to have it set up the correct way first. We need the same number in front of one of the variables,
Okay.
opposite sign.
Huh?
Same number, opposite sign. Now this one's already set up like that, so I'm just going to skip it because it's not a hard one to do. It's already set up that way. But you ask yourself every time, if I tell you you're solving by elimination, and you might ask this 3 or 4 times during the problem, do I have the same number and opposite sign in front of one of the variables? For example, I have the same number in front of the x, but I don't have the opposite sign. So I go now and I look at the y. Well, I actually have the same number in front of the y also, but I already have the opposite sign in front of the y, so I can go ahead and cancel the y's out. Again, I'm not going to do that one because we're going to do
You said
several
same
problems
number,
from that step. So again, what's our question we're asking from the very beginning?
Same number, different equation.
Opposite sign, write it down. Same number, opposite sign. Do I have the same number in front of one of those variables?
No.
Yes.
Oh, I
Where?
don't know yet.
Tell me where.
Oh, no, Lily.
Actually, we,
The one
yeah, there is.
Yeah.
Yeah, get him, Lily. Yeah, we do. He was just talking trash too, wasn't he? Absolutely, we have the same number. We have a 1 in front of both x's. We have the same number. But do I have the opposite sign?
No, not that one. You don't.
That I do not have. So here's what you do. If you do not have the opposite sign, that's where you have to take one of the equations
Oh,
Don't do it.
and you have to take one, and it doesn't matter which equation, just don't do it to both equations. Pick one of the equations. I'm going to do the top equation this time. I normally do the bottom, but negative 1x, so I flip that, subtract 2y equals negative 10. So I'm done with that. I changed that. I scratched through it. I could possibly come back to it later to solve for the other variable, but I might just use a different equation. Now, do I have the same number in front of one of the variables?
Yep.
actually, yeah.
Yeah, I already had the same number. I better still have the same number. I shouldn't have changed that. Now, do I have opposite signs?
Yep.
Absolutely. Negative, positive. Now I'm ready to solve. These cancel out, which was the whole, they better cancel out. That's the whole reason I just flipped the sign was to get them to cancel
That
out.
one goes negative 1.
And then this is negative 1y. I want just y though, so I need to divide and I need to include the negative.
Then equals 3.
So y is positive 3.
Yeah.
Now I'm not done.
Yeah.
Oh my
Do
God.
not have what x equals.
You have to pick one of the.
I would pick the easiest equation, so this one's easy to me. There's not any multiplication at all in that. So x plus y equals 7. I know y is 3. So that's pretty easy. I already really know what the answer is, but
4.
mathematically, I subtract 3 from both sides. So y is 3, x is 4. Just remember, if you remember that goal, I need same number, opposite sign. Same number, opposite sign. Sometimes it's already set up that way. Sometimes all you have to do is flip a sign, and then sometimes you can even figure it out by just looking at it. All right, so now this one. Do I have same number in front of either of the variables? First question. No, don't have the same number.
This is where you multiply.
This is where I say, okay, can I easily take one of the numbers, the lower number? It has to be the lower number. Can I easily take the lower number and get it to be 5? Can I multiply something times 2 so that I do have the same number?
No.
I can? Well, what are you going to multiply times 2 to get 5?
Multiply 2 times 5 to get 10.
Well, no, you got to multiply something times 2
2
to get 5.
2 times 5.
Oh, 2 times 2.5.
Equals 10, and 5 times 2 equals 10.
Well, no, you can do that. I'm going to talk about that in a minute. So if you'll remember, at the end of the last class, we learned a method where we just take this bottom number and we multiply it by everything. We take the top number and we multiply it by everything down here. That way works in this situation too. It gives you a bigger number, then it might make your math a little trickier because there's another way to do this. So again, is there a number that I can multiply times to an integer and get 5? Is there a number? Anybody think of one?
No.
No. There's not. I multiply 2 times 2, I get 4. 3 times 2 is 6. Nothing times 2 is going to give me 5. Is there a number though that I can multiply times 1 to get 3?
Yes, 3.
Yes. 3.
Yeah, 3, right? If you see that, if you understand that your goal is I just need to find some number I can multiply times this to get to 3, it's normally going to be pretty low numbers and you can figure it out. So I need to multiply this number, this 1, times 3. But I can't just, please refocus. You guys are getting a little out of control. I've ignored it for way too long. Yeah, I'm looking at you. So I can't just decide, oh, I'll just multiply the 1 times 3. Mathematically, we can't just pick a number. We've got to multiply times every number. It's kind of the equivalent of adding to this or subtracting. Whatever you do on one side, you got to do on the other side. Yes. So I need to multiply every number times 3.
We got like 10 minutes left.
More than that. That's actually fast. So if I multiply every number times 3, that'll give me a new equation. I can get rid of the equation I had. Now, do I have the same number in front of one of the variables?
Yeah.
Now I do, right? Do I have opposite signs for those numbers?
Yes.
Now I have everything I want. So now I can add vertically. You get 17x equals 0 or x equals 0. Now I need to plug that back in and solve for y. So if I plug x back in, basically 0 times 2 just goes away. So y would equal 2. I did a longer version of that yesterday. If you need to go back and watch that from 6th period, you can do that later. I want to make sure we get through the equations, though, which we did not get through that in the 6th period yesterday. So again, I'm not going to solve this one all the way out, but do I have the same number in front of one of the variables?
No.
No, I do not. Is there a number that I can multiply times something, though, to get the same number pretty easily? If you're not seeing this part, you can just do what Wonderson said that we'll do next. I'm not going to do it right here. You could just take one of these top numbers, 3, for example, and multiply every number here by 3. Then you'd have to take the 4 and multiply every number up here by 4. That'll get you a 12 in front of those y's. I'm going to do that in a second. Right now, does anybody see an easy way to change one of the equations so that one of the numbers will match up? One of the numbers in front of one of the variables.
Yeah.
What?
Wait, what?
One of the numbers in front of one of the variables. I want them to be the same number.
2 and 2 is 4.
So 4 and 2 look like there's some kind of relationship there.
Yeah.
I can multiply a number times 2 and get 4, right?
Yeah.
What number?
2.
2, right? Because if I multiply 2 times 2, I'm going to have a 4 there, which is what I want, 4 and a 4. But I have to multiply everything by 2 if I'm going to do that.
That's not going to work.
So now I'll multiply everything by 2, 4x plus 6y equals -2. But do I have the opposite sign? So I do have a 4 now, but do I have the opposite sign on that
No.
x term? No. So now I need to do one more change and flip the sign. Now I have exactly what I want and I can solve vertically. I'm not going to solve that one out. But if you did, I think I did solve that maybe in 6th period, so you can watch the video if you wrote that down and you want to see if you got it right. The x's would cancel out. You get -10y equals -10. So y would be +1. Then you got to plug that in and solve for x. Again, it's on the video from yesterday, 6th period. All right, so here's the last type of elimination type of problem. This is what Wonderson was talking about a minute ago. Do I have to say, so we're looking at 18. Do I have the same number in front of one of those variables in problem number 18? I do not. I do not have the same number. I got a 5 and a 3 and a 4 and a 9. There's also no way I can multiply something times 3 and get 5, or something times 4 and get 9. So I can't do that shortcut method. So here's the last way you have to know how to do it. I take these, I'm going to take these two because they're smaller. Like overall, 5 and 3 is smaller than 4 and 9. Again, sometimes there's not much of a difference. 2 and 5, 3 and 5, or 2 and 5 and 3 and 5, there's not much difference. I'd probably actually take the 3 and 5 because they're both positive. Here, I'd definitely take the 2 and the 7. That's much smaller than 4 and 10. Here, I would take 7 and 4. That's smaller than 8 and 9. All right, so, Anderson, dude, knock it off. You're like, no, you're worse than Ben. Seriously, what is your problem? Knock it off. I'm yelling over just you right now. So, I need to take this top number. Again, I circle both of them so that I know which variable I'm working with. I need to take this number and multiply every number on the bottom equation by that top number I circled. Now I take the bottom number that I circled and multiply every number on the top equation by that number. So 3. So times 3, times 3, times 3. Again, this way will work for that last set of equations that we did. Basically, anytime you don't have the same number in front of the variable, like if you answer that question with a no, you can always do this. Your numbers might be a lot higher than the other way, but that's fine. It'll still work. So I get 15x plus 12y. And as you notice, these numbers get kind of high. 15x, subtract 45y, equals negative 18. Oh, no, not negative 18. Hold on just a second. Oh. Oh. So now, I ask myself, do I have the same number in front of one of the variables?
Yes.
15 and 15. You better have the same number. The whole reason we just did this process right here was to have the same number. What? No. I just got onto something. You need to have a seat. And you were in the conversation. So have a seat. So I just did this whole process right here. So I would have the same number in front of that variable. If you don't have the same number in front of that variable, you did something wrong. Somehow. So you need to go back and redo that process and figure out what you did wrong. The only thing is I don't have opposite signs, so I would need to make one of them opposite signs. I'm just going to do the quick version and just do that. That's opposite signs. Now I have the two equations I can add. Last problem. This is one of the equations that you need to know how to, something like this. There's actually two more difficult equations. This is harder to do, something like this. You need to know how to solve a equation that has a whole bunch of steps. I take the 4 and I multiply it times both of those terms. I don't do anything over here yet. Now, if there's multiple terms on the left, like let's say there was another term with an n or another number, you would need to combine those. I don't have that in this one. I don't remember exactly what's on the quiz, but I think it's harder than this one. So now, I just took this 4 and multiplied it times a 1. That's how I got this 4. Positive 4. Positive times positive is positive. Positive 4 times negative 3n gave me subtract 12n, or plus negative 12n. Now, before you start trying to like, oh, I need to add 12n or add 2n and then add 2n over here. If you have more than 2 terms on one side, you can combine something. Guaranteed you can combine something. So on this side, I can combine something. Well, the only like terms I have are the n's. So I can combine those. So that combined, again, I'm not going to go into a lesson about how to do two negative numbers, adding two negative numbers together. But that's negative 14n. When you add two negatives, it is still a negative. Don't get your multiplication rules confused with your addition rules. So now I'm at the point where I need to start doing the adding and subtracting below to cancel stuff out. Because I can't combine these and I can't combine those, so now I need to start canceling stuff out. I don't want any variables over here. I want them on the left. So I need same number, opposite sign, just like elimination. So I cancel that. 14n over here. That gives me 8n, subtract 20, equals 4. Now I have a two-step equation. Again, there are some two-step equations also on there, so I hope you are comfortable with those. I want to get rid of all the numbers. So my first step, same number, opposite sign. I leave the 8 for last, because I always leave division for last, and that's going to be division. So there is a problem where you have to work out a more lengthy equation. I think that one's multiple choice, so that's good and bad. It means there won't be any partial credit, but it means when you get a final answer, you'll be able to look for it on the list, and hopefully if you did the math right, you'll be able to find it and you'll know you're right. Again, get here on time. Being tardy is not an excuse to get more time on a quiz. So be here on time. We will do from the moment that tardy bell rings. I'll start passing out. I even start passing out beforehand. Yeah, I'll just pass out. Once you walk in, I can give you your quiz. It'll be loud, but if you want it, you're fine with that. I'm fine with that. No phones though. Once I get the quiz out. I'm gonna stop the recording, and I'll post this one also. Those of you online, I'll email you your quiz first thing on Friday. Again, you'll take the same quiz, but I'll grade it differently since there's obviously no monitoring for what you do. Some of the things will be too easy for you to get help on or look up. All right. Have a good week and study. Do a little studying.